Right, yes, welcome everyone. As well, those of you who arrived early will have seen Charles's nicely put together little advert. The London show, which of course is not London this year, is on this Saturday. If you do want a link to that to join it, then go to the show website and drop us an email. We'll send you the link. Alternatively, you can watch it on the Wi-Fi Sheep YouTube channel if you just want to listen in and not participate. And it will also be on Leo's YouTube channel, so you've got lots of places you can watch it. I think, of course, what else? Oh, yeah. Of course, next month we've got the Building RISCOS Online, which will be very interesting. Right, for now, I'm going to hand over to, well, welcome back, Jason, who talked to us a few years ago about some of his projects. So this time he's going to talk to us about his plans for the RISCOS audio system. So take it away, Jason.
Okay, so hopefully everyone can hear me. I believe I've unmuted myself. I've also got my own little mute button on this little key fob here as well. And I keep forgetting, because this is the one I use at work, to do one or the other. So I'm normally muted. So I'm just going to share my screen. I think it's that one. So this is basically a little talk about a new sound system API that I've been asked to develop. So for those of you who don't know me, a little bit about me from my sound perspective. So my first ever sound thing was a bit of hardware for BBC Micro to do sound capture. About 30 years ago. I think I was about 17 at the time. And then I extended it to interface to an Archimedes as well as the BBC Micro. So it was like a dual purpose thing. You could plug one in the other. And then later on, met up with the Vertical Twist VTI people and developed 4 sound applications: Desktop Tracker, Sonar Junior, and Talking Canvas Junior. And these were sort of commercial programs that were sold with their sound capture boards. With Sonar Junior, that was the printer port sound sample, and Talking Canvas Junior was an extension onto that. At university, I did a 3rd-year project, which was to make a synthesizer. It did audio capture and playback using one of the Vertical Twist devices. I had a spare ARM3 kicking around, although I started off doing an ARM250, but a week before it was due to be handed in, accidentally got my 12 volts and 5 volts lines the wrong way round, and it started going up in smoke. So I quickly had to wire wrap an ARM3 instead. Later on, I developed a high-quality synthesizer, the VTX 2000, which was based on a Kurzweil chipset, which is one of the high-end audio manufacturers. That only had audio output, it didn't have any sound input capability, but the quality of it was actually really good. And also did some sound playback code for Fire and Ice, Dune 2, James Bond 2, and a few others as well. And since then, I've been creating synthesizers based on FPGAs, which are kind of like reprogrammable bunches of chips. So you've got a bunch of logic chips, put it all into one chip, and then you can reprogram, rewire it any way you want. And for that, it's sort of quite interesting because you got a number of different ways of doing output, and I use a protocol called I2S, which I'll come on to later, I2S, or IIS even. And basically it's a board with an FPGA. You reprogram it using a language called Verilog or VHDL, depending on which one you want to deal with, and you get it to make sounds. Interface it to MIDI, things like that, microprocessor, anything you want. And also, I like composing music. I won't play any of it, don't worry, not going to scare anyone. So, Stefan Froling, I hope that's the way you pronounce it, from Cloverleaf, asked me about Equinox, which is a game I developed quite a while ago. Actually started developing it in about 1993, rewrote it again in about 2003, and promptly didn't do much with it, although I did get it to recompile on the Raspberry Pi in about 2016, 17-ish time. And we got on to talking about audio input because of my work with Sonar. And he asked me to have a look at the audio input API, because there isn't one, and come up with an idea that could be reused by other vendors, software developers, to use a common audio input capability so that applications can use any hardware that's been developed. And that's what I'm going to talk about. So for those of you who don't know, how computer audio works. So computer audio is a digital representation of an audio sound. The most basic audio representation is called postcode modulation, or PCM, or linear postcode modulation, or LPCM. You've got three main parameters to this. So you've got the number of channels, one being mono, two being stereo, four being quadraphonic. The speed of the capture, which is how many times you chop up a second into individual bits. CD quality is 44.1 kilohertz. You get up to 88.2, 96 kilohertz. You can get multiples of this, but normally 44 kilohertz is the minimum that you'd expect. And then the resolution of the capture, again, CD quality 16-bit. You can get high resolutions for like mastering your own music, and then if you want to put it on a CD, you then decimate it down to 16-bit. So when you got some old sound inputs, you need something that will record each channel, i.e. left, right, left, right, left, right, left, right, at a certain sample rate, i.e. 44,000 times a second, and at a certain resolution, 16-bit for CD, and so forth. So audio buffers, this is basically used to reduce the CPU load. So what I have here, I don't know if you can see my pointer, on the top, you've got 2 bits of things that are using a buffer. You've got something that's putting sound into the system, which is in this case on the left-hand side. It's filling buffer 1, and buffer 2 is being emptied on the right-hand side by the audio hardware. So the sound playback is pushing data in, and then the sound output is pulling the data out. The hardware itself is pulling the data out. When one buffer gets filled, it switches to the other one, and then the other one switches over. And this means that you end up with a minimum amount of CPU usage, because every time you want to go into an interrupt, this causes the CPU to have to stop what it's doing, jump into a bit of code, do that bit of code, and then jump out again. So you want to minimize that amount of activity. And by the way, I ought to apologize if one of my cats comes and joins me. I just heard him come in through the door, so hopefully he won't join me. So early capture cards, they didn't have any of this buffering. So you couldn't get very high sample rates. You couldn't really do high quality playback either, because you would be spending too much time jumping between interrupts and non-interrupts. You also had poor quality from just low number of sample bits, so 8 bits, 12 bits. That was kind of the sort of quality you had at the time. And also software. I just realized I'm reading from 2 different slides. So I've got 2 screens, and one screen showing me what I'm going to be talking about next slide. And I apologize for that. Right, let's continue this slide. Anyway, so let's go back to this slide. Yeah, so with later hardware, you've got this thing called DMA, which allows the audio to be automatically copied from one area into hardware, or from one area of memory to another area of memory. And this reduces any audio glitches you have, because you've got 2 buffers that are going on. Right, next slide. That's what I started talking about. So with historically, you had 2 basic options. You had an audio input only device. So the output was provided by the native hardware, i.e. the RISCOS sound system. The audio, if you had an audio input output capable device, then you wouldn't use the native hardware. The audio output would actually come out of the podule itself. As you can see on the bottom right hand corner, the Claire's, I think it's Clarin. Anyway, that one's got a line in and the line out. So that one had its own playback. The one that I was involved with is this one on the top right-hand corner, which is the VTI printer port sound sampler, and that plugs into your printer port, as you may have guessed. So the early capture cards, they were low quality. The printer port sampler was 8 bits quality. I did make my own version of it, which was 12-bit, but then you ended up with a reduction in the sample rate, because the printer port is a very slow access media. If you had a piece of software, it was generally only written for that particular card. So, for example, our printer port sampler, Sonar worked with it, also worked with AMETHYST, if I remember correctly, but that was about it. But if you had someone else's card, it would only work with their software. In the mid-90s, Acorn started an initiative to have a general purpose sound sampling API, but unfortunately, it didn't really take off. or didn't really get anywhere until they went bust. So unfortunately, no one really got around to actually creating this interface. So on a modern computer system, they have built-in audio and output capabilities. So you've got a sound card which will have a number of inputs on it or number of outputs on it, and the sample will be recorded by the input and played back on the output. The actual interface talks between the CPU and the actual hardware. PCI would be common for a full computer system, but for an embedded system, there's this protocol called I2S or I2S or IIS. It's a very simple audio interface for linear PCM data. There's four or five wires, depending which way you look at it, for bidirectional audio. So you've got a wire for input and a wire for output, a couple of clocks, and something that tells you whether it's left or right. You've also got HDMI, but this is really for audio output from the system itself. You can actually compress the data across HDMI as well, so that allows you to have Dolby 7.1 sound, for example, over the same sort of interface that you'd have for a 2-channel interface. USB, you've got a number of different options for it. However, drivers for RISCOS are a bit of a problem. There's an example. I've got one here. This is the Steinberg mid USB interface. There's a USB port there. There's a couple of MIDI ports there, audio ports there, some more audio ports here, and some volume levels, and a headphone socket on that side. So this would be a great sound card, but getting it working under RISCOS, problematic. You can also compress the data when it's going over USB, so you can get higher amounts of high number of channels without compromising the USB bandwidth. And Bluetooth is another sort of protocol that's become much more prevalent in these days. We've got these Bluetooth speakers and Bluetooth headsets and things like that. However, there is no Bluetooth stack in RISCOS at the moment, and for Bluetooth, the audio must be compressed. It can't take linear data. So I'm going to talk about I2S because this is actually a very simple protocol. As I said, there's 4 or 5 main signals. There's one wire used for an input bit stream, one wire used for an output bit stream, one wire provides a clock, which is basically, this is when the data is changing on the bits, and one wire provides frame synchronization, i.e. which is left or which is right. So on the diagram on the right hand side, you've got the left channel and the right channel. That's the LR clock is known as the frame clock, or left-right clock in this case, and B clock is the bit clock. So the data in and the data out, this only shows one of the streams, would be a sequence of bits saying what the signal level is going to be at that point in time, and the number of bits depending on the quality you've got. So if you've got 24 bits, you'd have 24 of these numbers going along here. And one of the really good things about I2S is that you can actually have a 16-bit output chip, but provide it with 24 bits. It will ignore the remaining 8 bits. Likewise, you can have a 24-bit chip and only provide with a 16-bit stream, and it will take the first 16 bits, but then the rest of it will just say zeros. So it's a very good flexible protocol for where you got mismatch in the number of bits and the chip capabilities. Sometimes you might have a 5th clock, and this is a master clock for oversampling. Now, oversampling is a technique where you have the sound and it interpolates between 2 different samples to make it appear as though you've actually got higher sample rates than you've actually got in the system. With a modern computer system or modern embedded system, DMA will copy the data between the buffer and the hardware. So your software will be filling the buffer, and then the DMA will automatically pop each byte off and then pop it into the hardware, ready for it to play it. Or what the operating system would do is request the new data to say, here's some, can you give me some more data to fill up? Or it will tell the software the data is new present when you're recording. So creating an API isn't really something that I would say is easy. You've got a number of factors associated with it. So you've got to make it easy to implement. So i.e. If someone's producing a new piece of hardware, they've got this new thing they want to interface with it, it's going to be easy for them to actually integrate with it. If you make it difficult, then they're going to want to do their own thing. And that means it's no longer cross-platform compatible or cross-software compatible. You're going to make it easy to use for the application developer. So if you have something difficult, then they're not going to want to use it. Well, it's going to be too much work for them to actually integrate with it. And also, you've really got to make it backwardly compatible, because if there's an application that's really good at what it does, but it doesn't work with a new piece of hardware, then why would a user want to upgrade their hardware to the new facilities if they can't use their software? So an audio API, for it to be adopted, it's got to be hardware agnostic. So in other words, software must not care what the hardware is, unless it has to. It also must be extendable, so that you can put new features in without making it too difficult for a user or an application or a hardware developer to actually use those new features. If you make it difficult to extend it, then the hardware manufacturer who's got this new chip that does X, Y, Z is going to write their own API to allow it to do X, Y, Z. So adding audio input to RISCOS, I2S is actually an obvious choice. It's actually on the Raspberry Pi, 4 of those pins on the I/O pins, they are I2S, and that means that you can just plug in an I2S board. This is one I've got into it, and then you've got the capability of using I2S as an input-output protocol. We could look at HDMI, but you can't do audio input with HDMI. You could look at using USB, but you've got stack and driver problems. The stack's got to support asynchronous communication, which is basically a way of saying you can transfer. You've got a certain amount of bandwidth that you're guaranteed, which you need for audio, and also you need to get the drivers for the USB device that you're connecting to. And Bluetooth, quite a way away. We need a Bluetooth stack. We need to have encoders and decoders of the audio data. So I2S is basically the choice I'm looking at the moment. It's also the easiest one to implement. Now, because you're using I2S as an audio input, it shares a lot of the same hardware as the output. Sorry. So that means any change to the input needs to be also correspond to the output. And that means any data stream you've got that uses the input also has to coexist with whatever's being output on the output stream. Also, you should be able to match what capabilities you've got with the input and the output. So if you've got 24-bit input, but you can't do 24-bit output, why support 24-bit input? If you've got a 4-channel input device, why support it when you don't have 4-channel output? So that means I came at the thought that whenever you do anything with the audio input, you also must relate that to the audio output. So any feature you have on the input, you can play back on an audio output device. And it also means that they share the same underlying hardware. But we need to maintain backward compatibility. Otherwise, software won't work with it. Your games won't play. Your audio applications won't be able to sound anything. So looking at a new API, the RISCOS system has gone through a number of transitions. So the very first one for Arthur and RISCOS 2 was 8-bit MuLaw. And that kind of was around for quite a while until the RISC PC came out with 16-bit audio capability. That switched the audio from sound channels to a sound DMA module, also known as linear sound. After that, shared audio was added, and that allowed multiple applications to use the sound chip at the same time. So you can have your MP3 player, your game playing at the same time, and maybe some alert system in the background that might alert you to something that's happening. And then a later change was to allow the audio output stream to go to one of 2 different hardware devices, like your headphone socket on a PC or on your device, and also the HDMI. So this new audio will be the next transition of those phases. So the idea is to support multiple independent audio and input streams, output and input streams. So you can have your multi-channel device, and you're going to play audio, 6-channel audio on the 6-channel outputs, or we called 8-channel inputs on your 8-channel inputs. Support for 32-bit streams. So you can have at the moment 16-bit with RISCOS, but this little board, that would do 24-bit. Now 24-bit is not really a nice number for ARM chips to deal with, so make it 32-bit. And I don't think we'll need to go beyond 32-bit at this moment in time. If anyone can hear difference between 32-bit and 24-bit audio, I would be very surprised. We also want to keep the ability to have shared and non-shared audio applications. So if you've got an application that just really needs to play an MP3 in the background, then that would be a shared application so that you can have your system beeps and things like that going on in the background while the music's playing. However, if you want to have a music application that was able to support all 6 channels at the same time, then you really want to have dedicated access to the hardware. It also simplifies the way that shared systems work, in that if we make shared system only 32-bit stereo, then you don't need to do any up channel mixing, down channel mixing, and what have you. Just simplifies the whole system. And also want the ability to support compressed audio formats. And this is a future kind of thing I'd like to have in there, mainly for Bluetooth, but also for like Dolby 7.1 sound or USB devices. So the API will have 2 modes of operation for each hardware. So you've got shared mode and dedicated mode, as I've mentioned. Shared mode will be 32-bit stereo only for simplicity, and dedicated mode can use any format that the hardware wants. So if you've got your 16-bit, 24-bit 6-channel device, you can say, I want to set this up in a 6-channel 24-bit device mode. Applications would need to use the new API, but existing applications would be supported via shims, which are basically emulations of the old APIs. So shared sound and linear sound will still accept 16-bit stereo, but the shim then converts it into 32-bit stereo. 8-bit MULAW will be done as a shared sound mode implementation. So you've got your Maestro would still work in theory, although I don't know how many people really use Maestro anymore, but you may as well support it because it's there. Because it's going to take a while to develop, not all existing API functions will be supported. But the idea is that over time, the things that aren't supported will be supported. There might be some things that won't be ever supported. For example, the oversampling of 16-bit sound, that's better done in hardware than in software. So I think that will be one thing that might not get done. Now, for existing hardware, existing applications, we'll need to have one piece of hardware that's identified as the default. So it'd be like your headphone socket or your HDMI. And then the shared sound system would then go, okay, that one goes onto the default device. So there's 4 areas of interest in the API. Basically, the application that needs to use the sound. This is an extension of the current interface known as the buffer interface. It's currently well defined, but we're just going to extend it a little bit further to allow the 32-bit sample, and also the sample sample rates. Then we've got the hardware interface, which basically is the bit that the hardware talks to, and the hardware vendors would create interfaces for. This is an extension of the existing interface. You've already got implementations for the Raspberry Pi, for example, over the HDMI. You've got the RISC PC, for example, would have its interface. So this would be how the hardware would look at it. Then there's a new interface, which is the conversion of audio formats. Now this is, I'm calling it the codec interface. Now codec normally means encoder decoder, or compression decompression, sorry. And I'm using it as a general purpose conversion of one audio format to another format. So if you've got a piece of hardware, for example, that requires you to have PCM data, but you've got an MP3, then the codec interface will automatically convert the MP3 data into PCM. Likewise, if your hardware is a Bluetooth hardware and it requires the Bluetooth encoding, SBC, then you would take your application will have a linear PCM, and then the hardware would say, okay, can you convert this into SBC for me? And so you end up with an ethos or an ecosystem where the applications don't really need to worry about how you encode from one format to another format. It is the sound system that does this encoding for you. You just say, I want to convert from format A to format B. And it comes up with some code that says this is how you do it. And the shims will actually use this for backward compatibility. For example, the conversion of 16-bit to 32-bit would be a standard codec built into the new audio system. So the linear sound and the shared sound would say, can you convert this in RISCOS 16-bit format? Because RISCOS isn't actually the same as normal 16-bit format. Can you convert this into standard 32-bit format? And the software doesn't need to worry about that. It's all done in the background. And the final interface is the discovery interface, which is basically finding out about the capabilities of the hardware that's on the system. So a piece of hardware would say, I am a such and such device. I can support 6 channels, 32-bit at 192 kilohertz. And then the application can say, okay, which is the best sound card for me to use? Oh, it's that one. Or it's give an option to the user to say, which sound card would you like me to use? So I started development with documentation. This is actually probably an unusual way. I think some people might consider as the best way of starting development, but I do actually love documentation. I'm trying to make it look like the programmer's reference manual. So the font's the same, spacing is roughly the same. It's an A4 sheet rather than the slightly compressed format, but the data is going to be the same, and it's going to look very similar to the programmer's reference manual. And that allows me to actually sort of play with a few ideas to how I think the API would function in a new facility, and also how the shims would then interact with that API. The module name's been allocated. This is called sound system. It's only just been changed today, so there's still a reference in here to my the old name I originally had for it, which is called audio conductor, but it's now called sound system, which is a much better name, I have to admit. My previous name was a bit weak. So I'm using the Raspberry Pi, in fact, the one I've just shown you, with an audio input output hat, which is again I showed you. But I have designed my own general purpose hat. The one that I've bought only does audio output and has 2 microphones for input. So it doesn't allow me to do line in and anything clever, but I've designed my own one that will do much more, but this was quicker to get hold of and probably cheaper. Chinese stuff. But I will make the prototype later on. And also I have a source code repository for this code. And at the moment, the source code repository is called audio conductor, but I'll be changing that over the next few days. So I'm using Pure ARM assembler for speed, and it's built automatically via Jenkins and GCC SDK. So GCC SDK is, if you didn't know, a way of compiling, cross-compiling on Linux, RISCOS applications, and also assembly, which is what I'm doing here. It's automatically built every time I check in some code. So if I make a change, save it, put it in the repository, automatically gets built. And the documentation is actually included as part of the build output, but I'm doing that manually, but I'm contemplating ways of automating it. So on the right hand side, I've got the SWI that I'm using, which is registered device. Underneath there, I've got SWI registered device with comments in the code to say what the registers are. I'd like to pull that out and populate the documentation automatically from that. There's 3 modules I'm developing. So the main API module, which I'm calling a modular module, in that the code is actually modular in nature. So there's a thing that does the device interface, exclusive access, which is the thing that does shared or unshared access. The module header, playback, buffer handling, recording buffer handling, SWI handling, and unit testing, which I'll come on to in a minute. And also there'll be a reference Raspberry Pi I2S interface and a dummy reference interface, and this will basically be allowed to sort of test the buffer management and things like that. So proper development. Now I put this in here because one of the things I've learned over the past few years, or 10 years or so, is the importance of proper development methodologies. And the 2 things I really believe in is a source repository and unit testing. So traditional development, which is basically what I would say, what I used to do. I would throw code together, run it. Does it work? Yep. Okay, great. Oh, no, it doesn't. Right, I have to recompile it or whatever. Let's fix it. However, when I was developing in that way, I might miss something that a user would do. So a user might open up the application and click XYZ when I was expecting to do ZYX. And that might cause a problem. So putting the source code in the repository is a key thing. It's the next thing, basically, so that you've got a history of all your code and all the changes that have been made. If you've got multiple developers working on it, then they can share the development of the development effort, and you know who's changed what and why. And the other thing that I've got is auto build. This is where I mentioned I have this thing called Jenkins, which is a continuous development or continuous integration engine that basically looks at the source of project and says, have there been any changes? Yes, in which case I will go and build one. It can also control some slave machines for specific builds. So I have a slave machine that does Windows builds. I have a slave machine that does Linux builds. I have a slave machine that does GCC SDK builds. And the other thing is unit testing. I really like unit testing. So with unit testing, you basically write code to exercise the output code, i.e. you develop something that exercises a particular piece of code and make sure it functions in the way that you expect it to be functions. You can pick up errors with this code. So you give it, say, an edge case that a user might not do or might not do very often. And then you can just exercise this over and over again and make sure that it always does what you expect it to. If you get a bug report from a user, you can create a unit test that does exactly what that user does and then make sure that the code works. There is a technique called test-driven development where you actually develop the unit test first before you actually fix the code. But in some cases, you can just fix the code and then build a unit test to make sure it's still fixed, so you don't accidentally regress the code later on. You can automate unit tests, so it helps to, for example, if you've got a rogue developer who's accidentally committed some bad code, the unit test in theory should pick it up, assuming the developer hasn't removed the unit test, which can happen in commercial environments. It certainly happened at my previous company, which is rather amusing. It can also reduce the development cycle when you're cross-compiling. So basically, rather than having to wait for code, copy it over, run it on there, and then copy it back and find out problems and do backwards and forwards, if it's built and tested as part of unit testing, it's done in one complete cycle. And there's another technique called code coverage, where you execute the code and you find out how much of it is actually being called as part of your unit tests. So if you've got, for example, an if statement, you can see, do you go inside the if statement, or do you bypass it? And then you get a good idea as to how much of your code is actually tested. Now, unit testing doesn't solve every problem. And some developers don't like unit testing because they do take quite a while to set up and do it right. But I've decided that I really do like unit testing. However, RISCOS isn't really a good unit testing environment. So firstly, I have to cross-compile the code. And because I'm using ARM assembly, it's not necessarily the compiler's native code. I'm doing it under Linux on an x86 platform. So that means x86 is native code. Okay, fine enough, fair enough. I can't execute it. Also, as I'm developing a RISCOS module, I've got to emulate, I've got to be able to run the RISCOS interfaces, the OS cores, the SWI cores, and everything like that. So at the moment, the code must be executed on RISCOS itself. And that makes automation quite tricky. There is this thing called Eggplant that at my company we've used, which is the user interface testing program. And that basically interfaces to VNC and allows the computer to see what would be on the screen. And you can put triggers on it to look for buttons and text on the screen and then click on various things and see if it reacts. It's very good for user interface testing. But unfortunately, what I'm developing is not a user interface. There is also no Jenkins slave capability within RISCOS. And I have to admit, I'm not really feel like I'm going to write one. It's a lot of work. So I'm trying to do stuff which doesn't involve actually running the code on RISCOS. So I've come up with a project called AMETHYST. So it's an embeddable ARM emulator. I looked at some ARM emulators around, and basically they're all pretty much full machine emulations of ARM. And I don't need that. I just need to emulate small bits of code. So I don't need to emulate everything either. So I've got an emulator that doesn't do any mode switching, so I don't care if it goes into FIQs, IRQs, any of the SVC modes. I don't care about it. I don't have any CPSR instructions, i.e. moving the flags between registers, because at the moment I'm not using any of that code. If I need it, then I'll add it in. I don't have long multiply, I don't have thumb instructions, because at the moment I'm not using them. It's written in C++, and I've compiled it on both GCC and Visual Studio. The reason why Visual Studio is because that is actually my development IDE of choice. I know I'm going to be castigated for it, but it's what I've been using for the past 20 odd years. And GCC, so that it can be compiled under the GCC SDK. And it also has a customizable memory model. So that basically means I can create interfaces for my own memory. So I can create my own virtual memory space and look at the memory that's been allocated. I can create an area of memory that's a big block, but then subdivide it into multiple blocks. And the emulator thinks it's actually multiple blocks, but it's actually one big block of memory. It doesn't emulate an operating system, but it does allow SWI calls to be emulated via callback. So you register to say, this particular SWI, I want to call this bit of code. And it could, in theory, perform code coverage calculations, i.e. when it's executing an ARM instruction, it says, that one was executed, that wasn't executed, that wasn't executed. But I'm not using that, haven't implemented that, I'm not using it at the moment. So in order to test this, I had this thing called XARM, which I developed in 1993, which was an ARM assembler. I developed it with my third year project because I was developing it on my university's machines. We didn't have an ARM assembler. We didn't have a compiler. We didn't have anything. I had to do everything under RISCOS. But when I was in the office, when I was in university, I didn't have any of this. So I wrote my own ARM assembler. Now, when I started this, I only found this out the other day, that I actually started as a suite of programs. So there's XARM being the assembler, XARMD being a disassembler, and XARMS being a simulator. And I thought, oh, I've developed a simulator. I didn't remember that. But it turns out I never got it much beyond a framework. So it's like about 5 lines of code. The code, I then modified this XARM assembler to be embeddable. So you just pass in a string and a block of memory, and it then goes and assembles the code using a 2-pass assembler. So they end up with the instructions filled in. And that allows me to test the emulator much more easily, because previously I was just going, okay, well, look, I've got this bit flags. I need to set this value to 15, that one to that, and then try and remember how ARM assembly works. So this just makes life a lot easier for me. So going on from there, I'm developing this thing called ROOT, which is the RISCOS unit test engine. And it's an XML language for unit testing code. So the idea is that there's a definition which says, I want to load a module, I want to call the initialization code, I want to check that the memory's been allocated and populated correctly, and I want to check that, that the actual memory allocation routine was called. Now this is everything is pretty much midway through, but this is my newest thing. I've only really been working on it for about a week now. It uses AMETHYST as the test engine. Now, one of the problems I've got is when you use Objasm, you don't have a map file. Now, Objasm is the GCC SDK and also the RISCOS assembler. And a map file basically says this bit of code with this name is at this location. I don't have any of that capability. So I'm having to use macros in the assembler to mark a bit of block as saying this is something I can test. So what I'm going on to now, or going on from here, is I'm basically 2 phases of development. There's development of the sound system on the left-hand side. So I'm going to start off removing all of the existing audio APIs and start with my new bit of code. And then I'm going to start adding shims into it, starting off with the shared sound and then the sound DMA, which is the linear handler. And then finally the sound channel shim, which basically means you can use Maestro. Again, I don't know who uses Maestro. I have to admit, I'm not particularly fond of that bit of work. There's a lot of stuff in there that is a bit heavy in terms of timing that I'd have to catch myself up with, but because it's been such a long time. And the other thing I want to work on in parallel is the testing of the API with AMETHYST and ROOT. And finally, there's a couple of further ideas that Stefan's mentioned. Firstly, there's this thing called the RDSP, the RISCOS Digital Signal Processor, which is done by AMCOG. It emulates basically a mix of the sound interface device, SID chip from the Commodore 64, BBC Micro, Amiga, Korg M1, that's meant to say, and others together into a shared sound module. So Stefan would like to have that integrated within sound channels, sound thingy. Such a new API, I've forgotten the name now. A sound system. And the final thing is he's just asked about a thing called a data manager, which is similar to the codec part of the sound system, but for general purpose file formats. So you say, I want to convert, for example, put there a GIF to a JPEG, and you just say GIF input, JPEG output, give it the GIF, and you end the JPEG output. And the idea is it's meant to be a general purpose data translation engine. and you have these modules that provide these translation services for them. And the idea is that you just end up with applications that don't actually care what the sample, the original data is. It just needs to convert them into the right format. And the thing that worries me most about it is, this is a book I got in the 1990s that is called The Encyclopedia of Graphics File Formats. It's quite a compendious tome, and certainly not bedtime reading, and that was before most of the current file formats are available. So that one's going to be a lot of thought behind it as to whether it's actually even feasible or not. So that's it for me, and thank you very much for listening. Does anyone have any questions?
Not a question, but you and I should come and talk. Your Amethyst and Root are very interesting. You will be amused by my talk.
Okay.
Yeah.
Hi, Tony here. Thanks, Jason. That was really good. A couple of points there. I noted down. I was thinking about the fact you have the same number of inputs as the same number of outputs, and I was thinking of what I often do is audio mix down. So you have like a rack of synthesizers and like a mix down to stereo. That'd be like a use case. For doing it maybe differently. Any other suggestion I have was Doxygen. Is it something we've used at work?
Doxygen for documentation, yeah. I mean, I do want to certainly document Amethyst, and Doxygen. I've used Doxygen in the past as one of my RISCOS projects. Actually, used it. It was the second version of my RISCOS lib, not RISCOS lib, ROV lib library for WIMP application programming. So I do know Doxygen, but it's a question of whether I can get Doxygen to output something that looks very much like Programmer's Reference Manual, because I do like that.
You could do a transcode on it though. Maybe
that's what. That was about the only thing I could think of. Is if you just set up all the right style sheets and maybe XSLTs, then you might be able to do it. That would be fun. Whether it is economically fun or economically worth it, I don't know.
Well, I mean, even if you did like a pragmatic solution, just have a convenient input and then just formatted it, because it's fairly straightforward, like regularized form, isn't it?
Yeah.
But,
but going back to the thing about the different audio formats, the idea is that there would be a number of example codecs, and some of them would be mixed downs and resampling.
Cool. So I'll be able to plug in an array, say, of instruments, and then you could actually then take that out, or use it as an audio multi-track thing as a future app, for example.
That's the idea.
I'm doing a simple tracker at the minute because it was like a simple add-on. I wanted to use RISCOS for making more music, but then I need to get the UI right. I'm less familiar with that, so I'm doing it in stages. And then I wanted to add things like distortion, spectral inversion, to have some other filter types. I was, that's simple enough for me to do. I just haven't got to it yet. I'm trying to do one thing.
But you have just given me an idea that there could be a fifth interface added later on, which is like an effects.
Well, RDSP has a simple. It has simple delay, reverb, and like a digital chorus in there, which sounds reasonable. I wanted to add some more stuff, but having an effects, effects bus effectively is
exactly
a cool thing to do. Just so you can have a hardware thing, or just something done a bit more rigorously than some of the simplistic stuff which I've done.
I'll have a think about that. That would definitely be something that the API could be extended to later on. But I did have the idea of something that would be useful for audio capture, and that was really what the dummy interface was all about. And it would allow you to actually have the buffer, but then the application gets called that the buffer's been filled up by another application. That in theory could then be used as as
I do music as well, as you probably know, songs and stuff. So it's quite fun with that. That's cool. I was thinking unit testing I am in favor of. It's really good, but it's a bit challenging with RDSP because it has to sound good, and it's basically a transfer.
Unfortunately, sounding good is a bit of an AI nightmare.
Yes, complete nightmare.
So got a question from Peter. Backwards compatibility essential. Every new version of RISCOS breaks more software than we've written to using APIs. Yeah, that's why I want to make backward compatibility a key goal. It just wouldn't be something that would be immediately. So the first few versions of the software would be experimental, just to make sure that it's going along the right lines. But then when we start getting the new shims in place, and then existing applications shouldn't still work, then it'll be more production ready. Next one, can we have an API to play sound in the sampling background? I did consider that rather than having the wave synth beep, we now have a general purpose sound sample playback for your warnings, just system errors and things like that. Okay, so there's another question. Doesn't RDSP provide that? What does RDSP provide that mean?
Oh, that was me. I was thinking, doesn't RDSP provide a way to just say play this sample? It was answering Peter's
When
question.
it does the modulatable sample playback, you have to hook it through though to the OS in the right places fairly legally, which is the point. Yes, it does.
Sound file.
Kind of point it at the buffer with the sample in and say play this.
Yeah, it's trivially enough to do. It does actually provide general. I did a demo with that in there, but it's done crudely, just mapping the right frequency.
Yeah, you probably also want to have the sound sample rather than held in memory, held on disk. That's just buffering.
Yeah, absolutely.
Yeah, I mean, in the I made a comment. There's an existing program called Play It, which is bundled as part of with most versions of the operating system, and that allows with an appropriate driver, it provides an interface for playing a lot of common formats, just sort of either by star command or SWI.
Mm-hmm.
So that would solve the sort of background playback of
yeah,
a sample.
And that should also be usable as well.
Exactly. And that's actually how I did it in Music Man to play back CDs. It just creates audio buffers by reading them from the CD. Actually, it stores them, as crazy as it sounded, in a sort of temporary RAM disk type approach, and then just lets play it. It cycles the buffers around a bit like how Jason showed in his diagrams, and play it just queues them up and buffers them and plays them in the background. I actually used the triple buffer system, although that probably wasn't necessary.
Okay, so Dave, sound system was an old fourth dimension module. If it was, then they didn't allocate it, because I've just got RISCOS allocations today tell me that sound system was available for me. Timescales. This is a question I was hoping wasn't going to be asked. Now I was hoping to have an initial version sort of by the end of the year, and that's probably still doable. My work has kind of unfortunately sort of jumped out at me, but as of really the end of this week, that should be much more diminished. So I'll be able to spend a lot more time on this. Probably for a final version, you're probably sort of with all the shims and everything, March, but don't hold me to it, please. Okay, Paul, yeah. Okay, from Vince, not getting things allocated is very common and very foolish. I have to admit, I actually got everything allocated that I did, even if it didn't get released. Some SWI numbers I might have made up to start off with, but I would always normally allocate stuff.
Yeah, I think to get a SWI base, you need to allocate. So if 4th-D were putting out a module called Sound System that wasn't allocated, then it probably also wouldn't have a SWI base other than
I know
made up one.
I know there are user areas in there for SWI numbers you can use.
Yeah, but I mean, it's very dicey for anything put out publicly.
Yeah, I think my test one was always FEDC0. So user interface to select input out devices. Yeah, that we would need to have a configuration setting for sound devices, which would also include what sample rate to default them to. So shared sound, I'm torn between allowing shared sounds to change the sample rate or not to change the sample rate. If you change the sample rate, then all the shared sounds that are currently doing it need to know about the new sample rate, and that's something that's already built into the existing interface, if I remember correctly. But then they also need to basically resample their sounds either on the fly or try and pre-process it. I probably will make it so shared sounds can change the sample rates, but it will be maybe something a bit later. There will be standard codecs for doing resampling of the between sample rates. So in theory, an application would just say, I've got a 44 kilohertz sample. Here's my chunk of data. There's my output data. You go and do the conversion for me.
to follow up Stefan's question on about the user interface, some work on that has already been done because we already allow selectable sound output on the RMX6 IMX6
Yes.
build. So the sound configuration plugin in configure does actually allow you to select a sound output. The AMETHYST hardware allows both analog and HDMI audio, and the HDMI isn't always available depending on what capabilities of the monitor you connect are. So there is stuff in there to allow that to be done, but obviously it'll need to be expanded upon by Jason for
for inputs. Yeah. And by the way, hello Stefan. Didn't notice you there. Anyone else have any other questions?
So how simple would it be for me as an application or an offer to implement support for sound system in a cross-platform library like SDL or OpenAL or whatever?
I would need to have a look at that. I have done some SDL in the past, and my Arc Command game I wrote for Archimedes and RISC PC, which was based on the shared Sound DMA module, and also I did SDL versions for macOS and Windows and Linux. And that, I remember, wasn't actually too much. There wasn't too much difference between SDL and this and the Sound DMA API. And the idea is that this new API would be relatively similar to the existing Sound DMA API. It's just been a long time, about 10 years, 15 years that I did it. So I wouldn't like to say, but I don't think it's going to be massively different because they've all got the same problem. You've got your sound output, and you got your sound you want to output, and you've got a buffer you need to fill, and that you get that with SDL as you would get with this. So you'd have a bit of code that is called every so often to say, please fill my buffer, and then you'd go and fill it.
Yeah, the main thing I remember about shared sound that put me off trying to write an SDL driver for that. Or for that is, if memory serves, in order to have it in order to have audio in a multitasking web application, you need to get the buffer filling code into RMA, which looks to be a rather tricky when you don't have without the use of a nuller module.
Yeah, I mean, you've always had this problem within RISCOS in that the application itself may be paged out of memory when you're starting to having to fill the buffer. Desktop Tracker was actually quite advanced, and I have to admit I didn't write the play routine of Desktop Tracker. I just did the front end of it, and the guy who wrote the back end, the play routine, was an insane genius. And that on Archimedes, he didn't do this on the RISC PC, but on Archimedes, he actually did his own memory paging by manipulating memc, so that even in his interrupt routine, the application would be paged back in just to read the buffer, and then he paged it back out again. He was incredibly clever, but it's an insane way of doing it, but it works. What we do with Desktop Tracker on the RISC PC is we actually ended up using dynamic areas. So what you would do in the application is you try and put a largish buffer of your whatever you want to output into the dynamic area, and then you have your relocator module pull out the bits as it needs to go along to fill in the buffer more granularly, more refined. It is a very, very, very basic ARM assembly because I'm not using all the complicated stuff. I'm emulating. I'm not using complicated stuff. I did actually started something. It would have been early 2000s, which was running cross-compiled code using a RISCOS emulator. So I had my Wnt program written in C, and I wrote an interface to that also did GTK. so that I was able to run an application on both RISCOS natively and GTK natively. But it really didn't get that far. So it emulated the SWI calls for the WIMP initialize. So it had the underscore kernel OSWI WIMP initialize and knew how to do that in the GTK environment, and WIMP create window and things like that. But that isn't quite what I need here. Something I didn't quite, perhaps I misinterpreted when you were doing the actual presentation. Then is Amethyst of your own creation then? Yes. Ah, okay, sorry. When it first came up, I thought you were taking an existing building block. No, I started looking at the existing ARM emulators and I thought, oh God, they're trying to do an entire operating system, or entire machine, which then to try and extract that from there looked quite complicated. There's the QEMU one, yeah, and a few others. And I also started looking at them for inspiration. But then I thought, actually, it's going to take me longer to figure out how someone else has written one than to write one myself. Yeah, that explains why I hadn't heard of it before.
Have you had a look at JF Patch as a service?
Have you looked at what, sorry?
JF Patch as a service. It's a RISCOS build system in the cloud.
No, I haven't actually. That sounds quite interesting.
So that is not to advertise, but that's the topic of my talk next month, and essentially it allows you to build a bunch of code in the cloud and execute it as well on RISCOS. Have a look, but yeah. Okay.
Well done with the advertising there. That's good. Like
now Jason's got to tune in next
Sorry
month.
about that.
Right, so I've basically been asked about later version of the documentation. It's actually part of my auto build system. So I have a server, autobuild.tribbeck.com, and that has all my auto builds that I've made publicly available. There is there Amethyst there? I think there might be an Amethyst there, but I don't know I haven't actually looked at it. But anyway, there's the sound system is inside an audio conductor because I haven't got around to changing the name yet. And in there's a sound system .zip, which inside there's a doc directory, and then there's the PDF version of the document inside it. So that's where you can always download the latest one. I think the last build is probably about 6:15 today, because I only got the notification of the sound system SWI call today. I was quickly changing documentation.
Is there any, and this is a bit of a complete wildcard random question, so I do apologize. Is there any possible capability of adding in SDI support at all?
SDI?
SDI is a...
Oh, STI.
It's a broad, SDI, Serial Digital Interface. It's like a broadcast type format. And there's, I mean, normally it's been pretty close in terms of kit available, but there is Blackmagic do a USB one, which they've opened all the developer, or a lot of developer information on.
Yeah,
we've probably got stuff, but
well, we use SDI at work via interface conversion boxes. I'm not familiar with the underlying protocol or how it gets translated. It was something I need to research. But that manufacturer rings a bell.
Yeah, if you, there's quite a lot of information on the developer pages on the Blackmagic design stuff, and their cards are they're incredibly cheap for what they are. Actually, I mean, depending on which angle you're coming from, of course, but they're they're pretty nice bits of kit.
Yes, to mention, when you actually get to, or if you actually get to doing the AMCOG RDSP integration, please reach out and I'm happy to sort of restructure anything for you, because the main sort of sound function is a big block of C, because I wanted it to be quick, and it doesn't have to be, and there's some other parts there which we call it. Just, make life easy, please do reach out.
I didn't realize you were going to be online.
No, that's okay.
You've dragged everybody out, Jason.
Oh no, I'm not that interesting, am I? I didn't think I was.
Yeah, I'd be happy for an hour on the VTX 2000. So
Okay. Oh yeah, yeah. So I'll show you another piece of hardware that I developed, which was this. Which is my own RISCOS laptop. Hopefully turn on. Your lights are on. Yeah, come on, wakey, wakey. So it's basically just a Raspberry Pi inside it, with a few batteries, power switch, and an HDMI converter. But it runs RISCOS, and a little keyboard that happens to be exactly the right size for it.
Jason,
Yes.
I have a question. First of all, apologies for the nickname, because this is just a test Zoom account. I don't know if you went for that one.
Okay.
This is Paolo. So the question is, probably you answered it, but I'm having a day at work, so I want to ask it to be sure. Is the API also going to support, for example, audio hardware acceleration, like using DSP processors, digital signal processing, and all this kind of stuff? Or
I haven't thought of there's a question of what can we actually implement with existing hardware. Now, in theory, we could do things like the codec conversions of various different samples formats. That could be done in accelerated hardware, and that would be a perfect use for it. And that would basically be fairly easy to do, actually, because what happens when you register a codec to say, I can convert from linear PCM to MP3 or vice versa, is that you register with a pointer to some code, and that code can simply just take the buffer and then spit it out to the DSP, and then read the DSP, comes back in again. So that is kind of the way I'm thinking about at the moment, that could be implemented.
That's actually a good implementation. Yeah.
And there is another thing I thought about, which is called codec chaining. So if you want to, for example, convert from, let's say, MP3 to SBC for Bluetooth, but you haven't got direct MP3 to SBC, you could, in theory, convert from MP3 to linear PCM to SBC as a multi-stage processing. And when you say, I want to convert from MP3 to SBC, what happens is you end up with a fake codec that says, I can do this, but then it actually uses two implementations in the background.
I actually see this as a very useful thing to use on a potential RISCOS port for the MR board, because the MR board has an ARM to double core. Then it has the FPGA just fully attached to the CPU and has access to the cache as well as the same memory.
Is it based on Zinc? Xilinx Zinc?
I think so. I don't remember right now. I have it here, but I have to look.
Because now the Xilinx Zinc FPGA has a built-in an embedded ARM processor within it.
Well,
it's a multi-chip solution.
Right, but it should be an Altera because it's Intel. At this point.
Intel. Who did they buy for their FPGAs? Altera. Yeah, that was it.
So it should be an Altera. I just don't want to say something funny because Leo is recording this. It will stay forever that I mentioned someone else. But yeah, I mean, in that particular case, that could come out like a very powerful audio device running RISCOS for music and whatnot. And also because that also has extra boards already made with digital audio and potentially, the possibility to control also a form of audio output.
Yeah.
Could be a market for RISCOS.
Sounds good.
Thank you very much. Oh, and by the way, thank you very much for the presentation. It was great.
Thank you. I just sorry, lost my way halfway through, quarter of the way through. Can't believe I've done that. Because I've got these two screens. And I was going, oh, yeah, because I want to look at the camera, but it's on the other screen there as well. I've got my presentation.
Yeah.
So unfortunately, my main laptop screen's a 4K screen, and I didn't really want to waste the bandwidth, so I got a 1080, actually not 1200 screen, 1920 1200 screen to the right, and that's where I put my presentation. I knew that would be a better bandwidth save than trying to put it on the 4K screen. It's not quite as bad as my boss, who took hold of my laptop and managed to configure it so that I now need 3 screens to view any PowerPoint that I look at. Haven't figured out how to stop that one yet. I can't be bothered.
Just a quickie question here. we've talked about audio in and out. How would that link with MIDI as well? I mean, I'd like to see a MIDI sequencer in RISCOS, but if it was playback, recording audio in RISCOS and just MIDI playback, that'd be fine. And then, you know, possible musical instruments using RISCOS, you know.
Yeah, I mean, I do have a number of software synths on my PC, and I have developed my own ones. June 2, for example, was actually a MIDI engine in the background that was controlled by MIDI-like SWI calls from within the game engine. The thing is, MIDI and audio input and output are actually very different beasts.
Yeah.
MIDI's got its own separate SWI and time management thing. You've got the SMPTE manager, which we probably want to integrate with as well. So at the moment, I haven't really thought about integrating the two together. That would still be down to the application. I mean, what you generally need is some form of high resolution, accurate timer. To do proper synchronization of everything. That might be another piece of hardware in its own right. If you can't get the timers on the system itself, you should be able to.
Yeah, I was just looking at, I mean, obviously in the PC world, there's millions of interface boxes, MIDI and audio. And for me, that's what I use. I've got a whole load of hardware synths in the back bedroom there, you know, so it needs to be MIDI as well as, even if it's playback only, because I can write it on one thing, transfer the file. But I just love to use RISCOS because it just works so easily, you know, and PC and Mac stuff, you sort of go, oh, come on.
I fully understand that. We did, when we were VTI, we did start talking to Cubase about doing a port to RISCOS of that. And then because they more or less said no relatively quickly, we looked at Cakewalk.
Right. Yeah.
But unfortunately, nothing really came of it. And then for a while, we even started talking to Sibelius about doing the reverse, so doing a Windows port of to make sure they end up doing themselves.
Yeah, because unfortunately, of course, the RISC PC and you know, the next one that it should have been all came at the wrong time, and I think RISCOS 4 threw a lot of stuff out the window that we just got going. I think we're looking at one of the major sequences was getting audio into it, and they had their sequencer and audio ready to go, and it just went, unfortunately, wrong year. You know, another year, I might still be using that.
Yeah, I remember going to Acorn's offices to talk about their audio input API. And I thought I had the documentation somewhere around, but then someone posted it online not so long ago, so it's there. And what was written there was pretty much how I remembered it. Yeah.
Well, thanks very much for all your work you've done so far. Hope it all continues. We're looking at Easter now, of course, but are you looking at basically a Pi device because it's got this built-in bits and bobs?
It's basically because it's cheap. I've got the hardware. There are other options that would be available to me, but at the moment, like I say, I got that and got that. Two together. It just means it's easier, and also I can attach logic analyzers onto it, so I can see what exactly is happening with the signals. With my previous history of creating synthesizers with FPGAs, I've done that before, so I kind of know what to expect from the data stream. If anything goes wrong, then it helped me debug the problem.
I must say, anyone who writes software way past my head. So very glad somebody does it. Thanks very much. So
are you more of a user or a hardware person?
Well, a user of RISCOS for donkey's years. I'm in the rock club. We got the first machine in 1990, and it still works. You know, that's the annoying thing about the PCs. They've sort of died via various OSs. And I've got used to hardware since. So I think I've got about 5 modules lying around. So that's why I was in the MIDI side of things.
You know, I got 4 hardware synths. So I've got a Kurzweil K2500X, if I remember correctly. Kawai K1000. Kawai K5000. Sorry.
Right.
An Access Virus and a little portable XG device that you can record your own tunes on and everything. That one I don't really use, but the other 3 I do.
Unfortunately, I started off in exactly the wrong way by being the right way. Managed to get a Moog Prodigy for 120
right.
quid,
Mhm.
donkeys years ago.
Yep.
Absolutely brilliant. Then I got an Oberheim OBSX that was completely out of tune. Every voice card was out with itself, everything else, and the scale. And before the internet, I think it took me half a year to tune it. Yeah. Just all by ear and guesswork. You just have a look at these presets and go, well, try that. Yeah. But yeah, I just enjoy playing with all that sort of stuff. And I've got background in electronics on the analog side. So I mean, like I've got a Kawai S100P preset, which I'm going to pull some knobs out of because I know where to stick the wires and what have you. So I'm retired now, so I just enjoy my time doing that and making up tunes and what have you. But yeah, I'd just love to do stuff on RISCOS for as much as possible, really. So,
okay.
Well, thanks again. Okay.
Jason, speaking of MIDI, if there's going to be a MIDI API, which would be great, because actually we had a very good one, which is MIDI support, but that is a proprietary silicon Vision liquid silicon. Sorry, I forgot the name. Apologies, I never remember the name.
Andy at Expressive Software Products was the main guy behind MIDI support.
Is it going to be released?
I haven't spoken to Andy for a while, but if the sound system is going forward, then it would make sense for me to try and reach out and find, see if I can get back in touch with him.
Yes, please.
As far as to Peter, there is actually USB MIDI now on RISCOS 5. And that has got to a reasonably decent state. It can be used with programs like Rhapsody. And I think some of the old, what was the name of the company? The ones that did CineWorks and MIDIWorks and all that lot. Oregon.
They never got that big system going together as they last days of RISC PC. Yeah.
The guy who did some of that came back and he updated AudioWorks, I think it was, to run on RISCOS 5, and I think
really,
I think the one that combined things together, Studio Sound.
Yes.
I think that's been updated as well.
Oh, right.
I think. So there are, there is software and there are hardware interfaces that you can connect your hardware MIDI up to right now. So
MIDI support, I had problems to run MIDI support even on the Ionics.
MIDI support's still a problem, but the actual USB MIDI stuff for RISCOS 5 does work to allow the use of MIDI. There's a guy in France who's been particularly pushing forwards with Rhapsody, and that's now sort of working quite nicely on RISCOS 5 plus USB MIDI. So,
if it's going to be released open source, I'm offering my help, whatever I can do. The support help, coding, whatever, debugging, whatever they need. But definitely, super happy to support the MIDI API.
Sounds like I need to dig through my emails again.
Yes, please. I mean, it would be super cool on the ARM book. Because the ARM book is perfect for sitting on a keyboard on top of a synthesizer. Has the extra USB port, can be used with the MIDI over USB driver that is available now for RISCOS 5. So it's lacking just MIDI support. Yeah, and then obviously convert application.
We'll see what we can do.
Thank you so much, sir. You're amazing.
That'd be really useful to have MIDI on the ARM book. I've got an ARM book at home. The other nice thing will be if you can just activate the microphones inside it, and I can just whistle a tune in, and then seriously, if it's there and it's on, I can just think up a tune. If I'm not in the music room, walk around to the room, play it back, off we go. Let's go and do that.
I agree. I mean, the ARM book with a touch screen and MIDI over USB would be a killer musician application to have on the keyboard.
Touchscreen's a bit of a tricky one at the moment, but
well, you can apply a touch screen on top of it. There are.
Or let's just say that there's a reason why I want to do a Skype call with Jason tomorrow.
Let's start with that. Yeah, sure.
I just remember that I was going to ask a favour. If anyone's got a copy of Archimedes World 1993 July, I'm interested in the comparative review of Desktop Tracker, Digital Symphony, and WIMP Tracker. Because I remember reading it at the time, and I remember it's being split across multiple pages. I'd just love to have a copy of the comparative review again. I haven't found one online yet.
Must have it. Don't know where it is.
I think I've got one somewhere as well, but I don't know. I used to keep anything that was a review of anything I've done or of the company.
I never throw the issues out, but
if anyone can find it, I really want a copy of the comparative review.
If you can just repeat that one for us.
It's Archimedes World, July 1993. I've got the front cover.
Okay, yeah, I've got many magazines at home, and
don't break yourself doing it.
I'm retired. That might be tomorrow's job. See if you can find it.
But don't want you to put a box and it suddenly land on you, and I'll be very guilty.
There's things in the garage and things around the house. I've been sort of told off for having too many magazines. But if they're not being scanned by somebody else, there's always going to be something in them, isn't there? So I'll have a look with that one for you.
Great, thanks.
If nothing else, the museum, the Centre for Computing History has it, and they have an exhibit ID reference as well. So if you Archimedes World, July 93.
Yeah, that's the front cover I've got.
All right, but nothing inside. Yeah.
Presumably they've got the rest of it.
I'm hoping that's the case. But yeah.
Slight tangent, but can you tell me a bit more about Desktop Tracker?
What would you like to know?
Mostly, and just an overview of its history.
Okay, so originally, the company I was working for, VTI Vertical Twist, they were kind of spun off from the Serial Port, which was set up by Hugo Fines and Andrew Foyle. They had a bit of a falling out, so Hugo Fines took the Serial Port and the Tracker application, and we wanted our own version of it. So we found this guy called Christophe Thivand, who's a French programmer who was developing a Tracker-like play routine. And we had a little discussion with him. We came up with an idea to do a desktop version of Tracker, but then have the ability to have more it's kind of like functions or operators on the sound, because with normal Tracker you've got a note, a sample, a volume, and then you've got an effect. So it's effects, that's what they're called. Effect like pitch bend up, pitch bend down, vibrato, things like that. But with Desktop Tracker, we wanted to do something a bit more fancy, so we allowed up to 4 effects to be per note. And Christophe came up with a really neat way of allowing us to do that by having each note, each block done as either 1 word or 2 words. So there was a bit that said that it's a single word, or a bit to say that there was it was 2 word, which had up to 4 effects. And I remember we received drops of the play routine with documentation on a floppy disk via post to our office in Chichester where I was working. And we were a kind of mail order company as well as being software developers. So in between picking up orders for modems and RAM and things like that, I was programming Desktop Tracker. Yeah, it was sort of fun. I mean, we had a few complaints about Desktop Tracker not quite playing Amiga formatted samples correctly, or Amiga tune, sorry, correctly. In fact, bastardization, I think, was one of the words that had been banned by one of our competitors, which is okay. They were kind of right. What we were doing is treating stuff linearly, which is probably what some people would have thought, whereas with Amiga it was logarithmic. But we did eventually put a flag in to switch between linear and logarithmic for, I think it was the pitch bend and the volumes, I think is what the 2 effects, or the 2 things that we're complaining about most. But the really good thing about Desktop Tracker is also we had 16 channels, which was pretty good even for a an 8-channel only Archimedes. So we did interleaving of samples, which is something that no other program did. The other thing it also had was a very fast play routine. I can't remember the exact value, but I think we got about 10% CPU on an ARM2 with 8 channels. I've got a graph somewhere for it. Now, I did actually write an even faster play routine many years later. That was about 3% on an ARM2, but never released it because at the time 16-bit came out shortly afterwards, and there's no point in really having an 8-bit sound system anymore. So unfortunately, while we did the upgrade to RISC PC, we didn't do anything beyond that. So Christophe, I think, ended up, because he was French, in the that he had to do national service, and then we kind of lost track of him after then. So we never got around to it. I have written a program that disassembles modules and puts it back into source code, and I've tried that on Desktop Tracker, and it's not the prettiest thing in the world, but I have kind of been trying to pick my way through it to figure out how he's written some of the code. And that is actually something that I might release at some point, is the module disassembler. But we did have one that was written in BBC Basic that we got from somewhere, and it's modeled on that to an extent. So it looks through the code and tries to work out, is this actually code or is it data? And if it's something that that isn't quite right, you can then mark it as being one or the other. And then I'll try and produce a basic disassemble version of the module.
If you do release a new version of it, what are the chances that you could add import facilities for other tracker formats?
Well, that's actually not too bad. The actual import of files has nothing to do with the play routine, because you just need to convert it into your own format. In theory, that should be doable, even with the current version. I mean, I wrote the front end, so should be doable. The only thing is, I would say the code is pretty ugly. Yeah.
I'm just thinking in terms of my old stuff, which was all written in Tokenizer format.
Oh yes, I remember
Tokenizer. It's now all in Mod Plus Tracker or Screen Tracker, one or the other format on the Linux box.
Yep.
And it's lost a lot. The conversion's lost a lot of the things like fades and whatnot, so all needs to be re-implemented.
Yep. I've still got a load of stuff on Desktop Tracker format, but unfortunately it's compressed to Desktop Tracker format, and I have a feeling I've lost the source code to the decompressor, and it's ARM assembly. So it's not going to be too complicated to decompress, but yeah, it's just, oh god, I can't get it back out again now, even if I wanted to. But certainly it'll be a bit of work, but yeah, it'll be doable.
Bit of a long shot, but were you involved in the Archimedes version of Simon the Sorcerer at all?
Yes, but not in any way that you would expect. There was a WIMP front end for you to launch it, and that's the bit I wrote. I think Simon the Sorcerer was that. If it wasn't that, I didn't do anything.
Yeah, I know. Yeah, I know that the floppy version uses Desktop Tracker for the music.
Yes.
Nick.
Yeah, I think we wanted to sell our own wares, as it were.
Yeah, uses it. It also uses it. It's compressed. I think it's compressed using some custom routine. So not the one that's actually part of the Desktop Tracker format you mentioned earlier. But
okay.
But as far as I can tell, other than that, it's pretty much identical to the Amiga version.
Yeah, I can't. I wouldn't like to say how it's compressed, but it's possible that some of the source developers were sort of independent, subcontracted to do it.
Oh well, it was worth a shot.
Yep.
Anyway, thanks for that. It's quite interesting hearing the history of it.
That's okay. I could spend absolutely ages talking about it, but I'm sure some people fall asleep. if not me.
Notice people in the chat are now going into suggestions of which program should we port to use this new sound system.
Yeah, I mean, I agree. Audacity is the one that I've used quite a bit of. There are some quirks with Audacity, but in general, it'll be great for it. You know, I personally, I would actually upgrade Sonar to do it. I did start working Sonar 2, again, mid-90s, to cope with more like 16-bit sound format capability, stereo sound, and it was going to have an FFT display on it as well, so running along with the actual sample, but I had problems with that, and it kind of ground to a halt as a result.
Do you still have the source code of that though?
Probably. Just having a think, because I've basically got all my hard disks and need them on Linux, so I'm able to actually mount them as ADFS using the Linux ADFS mounts. And I've found source code for various bits and pieces. The only problem I've got is there are 6 hard disks, and I normally just mount one at a time. And I've probably got about 3 different Sonar 2 directories. And I have to find out which one's the most recent of them. I think one of them is just a set of icons I've designed, and the other 2 might be source code. But that's how I found my assembler. Was I just mounted the disk and thought, oh, there it is. I had completely forgotten why I'd written it until much later.
Yeah, of course, Sonar's open source again now, isn't it?
Yeah, if you fancy looking at my really bad old source code, which I probably want to disown now, but I too late.
Yeah.
The main thing with that is actually probably more Sonar sound, the relocator module behind it. That is basically done as a sound channels implementation. So it's the 8-bit mu law sound system. Yeah, it doesn't do sound DMA or anything like that at all.
Okay.
In the interface you've proposed, I don't see any support for balance left and right.
Not in the documentation as it currently stands, but some of the earlier documentation mentioned it to do with. Actually, no, there might be actually something in there.
I couldn't see it. I'm sorry.
They're probably not at this moment in time. Just having a look at it. No, but let me just have a look at some of my earlier documentation.
I mean, it's rare to need it, but
yeah, because what I was looking at modeling it on was there's in USB, not USB. Yeah, in USB there's things to say what mixers you have and things like that. And it was around that area.
Yeah.
But I have
the other things. Go on.
I was going to say I have a feeling that I haven't put that in there yet because I want to get the initial buffer stuff sorted out, and then this would be like a more of a side channel event. So the idea is that we've got the sound control interface. It'd be similar to that.
Fair enough, because I'm assuming that would also include, if it was available, bass and treble controls or anything more clever. As you've seen, USB audio does have a crazy number of things you can wire up in it, which are not supported by hardly any devices.
Well, they're trying to be forwardly compatible.
Yeah, just not very. And also USB devices, if you don't wire them up in the right way, generally don't work, which is part of the course with USB, I think.
Yeah, I'm just having a look. I mean, I got vague mentions of it in some of them, but I know I have thought about it. I thought I'd written something on it.
Quite okay. Just curious. That was all.
Because I've written 4 PDFs. I think I've opened them 4. Can't find it.
I wasn't expecting anybody to have actually read the document, Jeff.
I've been rapidly reading whilst we've been chatting.
This is a random one. In terms of some of the old BBC Micro stuff, some of that hardware was used in pop songs and used in other famous things, probably without the acknowledgement. But are you aware of any of the stuff that you've worked on, particularly in the RISCOS sort of era, being used to create sounds that were used in, well, any kind of pop songs or TV or anything like that?
I wasn't that famous. No, I can't think of anything. We did have a kind of an in-house music person whose name escapes me at the moment, and he did do some really good tracks using Desktop Tracker. I remember him doing a remix of some Jasper Carrot speeches. So he basically put music to Jasper Carrot talking over it, so kind of one of those types of tunes, and that was really good. I don't know what happened.
Not Funky Motorcycle then.
No, it
Well,
was
the B-side. The B-side was brilliant.
okay.
It was a spoof Magic Roundabout thing.
Okay.
I can tell you that the VTX 2000 is still being used professionally by a local musician here.
Wow. Okay, it still works.
Yep, I had one of the few that were made back in the day.
We
And
made 5.
sorry.
I think we made 5.
Yeah, I had one of them, and it's one of my treasured possessions, and I have it. It's on loan to the musician, for professional use on the terms that it comes back to me when
it no longer works.
Well, when he's finished doing what he does with his RISC PC.
Okay.
But it replaced a failed Roland sound canvas, and sort of it was a better solution anyway. So he was using that. He still uses Sibelius to do commercial compositions, and they require, his customers require samples of what his scores look like or sound like, more to the point, and all that's done on the VTX 2000, and it goes out commercially. So
that's impressive.
Probably nothing that most people will have heard of, but nevertheless, there's a product still being used to this day.
That is very good, and I think I do have a VTX 2000 myself, and we unfortunately we designed it with grand ideas in mind, and VTI didn't actually want to make it. So a friend of mine and I set up a company called Arm Designs to make it and sell it to VTI, who then sold it on to the end customers. And due to a slight miscalculation, Arm Designs ended up selling it at cost to VTI. In fact, we actually sold it for less than cost, but in order to recoup it, we ended up having to be VAT registered, so we can claim the VAT back, and that ended up being a net value of 0. So our VAT, we did VAT returns for 5-6 years, and all of them was 0, 0, 0, 0, 0, 0, 0. But because you could voluntarily do VAT, it was fine. It was a bit of a nuisance every year to do that. But we made it at the same time as the manufacturers decided they didn't want to sell it.
It was remarkably good value for what was,
Yeah.
It was a sort of £1,000 synth on a card for 300 or something.
Yeah, it's the main reason why I've got the full-size Kurzweil K2500 keyboard as one of my main synths, or it was my main synth for a while, but now I mostly do software synths. It's just a bit more convenient. But I do have software synths of analog, or emulations of analog units, because I love some things like the Jupiter 8 and things like that.
All I can say is I love that card to bits.
Yeah. I do as well. The one I've got, I think, is a returned one where someone had managed to blow up one of the transistors on it, but I don't know what the transistor is to replace it. I do have a Yamaha XG card that can go in there instead. But unfortunately,
I had one of those as well, but the K2000 card was always the.
Oh yeah.
To my ears, it was so much smoother.
Mm-hmm.
Speaking of which, guys, it would be totally awesome to have the DMI 50 working on my Ionics. Unfortunately, it could potentially do that because the driver is being converted, but MIDI support has problems on Ionics, and that's a big issue because the Ionics is much more quieter than the RISC PC. So it would be super cool if somebody at Liquid Silicon is listening.
Just a little interjection here. The Kurzweil things were helped to be developed by Bob Moog. if you didn't know that one, which may explain why they sound good.
Yeah. Hey, when we first heard it, we kind of were blown away by the quality. I mean, it's a little bit dated now, but it's still pretty good.
Yeah, I think I got my I got one of those DMIs, but I got the Ensoniq one, which isn't as good, but still fairly good.
Right. So I don't know if anyone's got any specific audio audio API questions left, or whether we should kind of,
Or anything on my history. I mean,
or whether we should make this a convenient point so Leo can stop the recording and we can all go into completely off-topic chat if we want to. If no one's going to jump in, I'll just say thank you again, Jason, for coming along.
That's okay, and thank you for inviting me.
And we look forward to inviting you back about March, April to show the finished product.
Well, tell you why it didn't get done. I'm definitely got a nice gap at the moment. I've got a holiday to take off from work that they need to give me, so that would definitely allow me to get my time. I was hoping to do more work on the on it while I was actually on holiday because I had a late holiday in September to a static caravan in Devon. And that's why I started AMETHYST, really, was so that I could develop it remotely. Did get a bit of work done, but my wife wanted to play cards instead.
Well, maybe by the time you get it all finished, we'll have a real physical meeting and we can invite you down the pub to give you a drink for it.
That sounds good.
Right, so that's it. Thank you very much for coming. And we'll,
That's okay, thank you very much.
Leo can wrap it up there. Thank you very much.
Thanks, Jason.